The STM32F401 microcontroller. The STM32F4 family of microcontrollers, they are based on ARM Cortex-M4, which has a floating point unit. And these microcontrollers are more powerful compared to the F0 series and the F1 series, which are based on the ARM Cortex-M0 and ARM Cortex-M3. And this STM32F4 series is also divided into few subfamilies, and these are the access line, which is the most basic STM32F4 series microcontroller, and they have a frequency of 84 megahertz or 100 megahertz. And then comes the foundation line, which is a bit powerful compared to the access line. And this foundation line, they can run up to 168 megahertz, and a few microcontroller can also run up to 180 megahertz. So these are fairly powerful compared to the access line. And after the foundation line, we have the advanced line, and they are the most advanced microcontroller in the entire F4 series. And their clock speed is 180 megahertz, which is very fast. And this advanced line also has some advanced peripherals like the LCD controller and the SDRAM interface. And in this video, we are going to discuss about the STM32F401 microcontroller and the STM32F411 microcontroller. And both these microcontrollers belong to the access line. That means they are the most basic STM32F4 series microcontroller. And this also implies that they are also very low cost, simple and low pin count. Or when you are developing a device which is very cost sensitive, then it is advisable to choose one of these microcontroller from the access line. And if we compare F401 with F411, then 411 is more powerful compared to the F401. So this STM32F401 is the cheapest STM32F4 microcontroller that we can use in our device. That is why I have included this in our course. So when you are creating a very cost sensitive device, then I recommend you to choose this 401 microcontroller. And in this video, we will learn everything about this STM32F401 and STM32F411 microcontroller. So let us begin. So when I tell STM32F401 or STM32F411, I am referring to the base name of the microcontroller. This is the base name of the microcontroller, and there are different variants available of the same microcontroller. And what do I mean by variant? So ST provide the same chip in different variant. That means the same chip is available in different memory configuration. One variant can have 128 kilobyte of flash memory, while other variant of the same chip can have 256 kilobyte of flash memory. In the same way, there are 384K and 512K variant of the same chip. So these are called variant. The chip is same, but the amount of memory present in the chip is different. And another parameter is the pin count. So the same chip is available in different pin count. For example, if you go to the web page of this STM32F401 microcontroller, you will find out that the same chip is available in 48 pin variant, 64 pin variant, and also in a 100 pin variant. So this gives the designer a lots of flexibility in designing their product. If in the future their firmware become bigger, they can simply choose the same chip with a bigger memory, and then their firmware will easily fit into the chip. So the first thing you must do in order to understand this chip, you must download the datasheet of this microcontroller. That is STM32F401 microcontroller's datasheet. And in ST's website, you will find two datasheets for the different variants of this microcontroller. One is for lower memory group and one is for higher memory group. So one datasheet, they have covered the 128 kilobyte and 256 kilobyte variant, while in the other datasheet they have covered the 384 kilobyte and 512 kilobyte variant. So you should download both of the datasheet and then study them. And from the datasheet, we should gather some key information and note it down. So the first parameter you should look for is the speed of this microcontroller. For that, just open your datasheet and go to this section, the description section, and scroll down a bit. Here you will find the detail of the chip. So look at this table, table 2. So this table 2 is divided into two columns. One for STM32F401xd and another for STM32F401xe. So what are these D and E? This last D tells you about the amount of flash memory that is present in the chip, and D stands for 384 KB and E stands for 512 KB. You should note it down. So in this table we can clearly find out that both of these variants, they have 96 kilobyte of RAM. This is a very important information, and you should also note it down that the STM32F401 has 96 kilobyte of RAM. But if you open the another datasheet, that is the datasheet for the variant which has lower memory, you will find out that they have 64 kilobytes of RAM. And here in the bottom you can see the maximum CPU frequency. This is a very important parameter, and you should remember this. You should also note it down and remember this. So we can see that both the lower memory variant and the higher memory variant, they both run at 84 megahertz. And the next thing that you should pay attention to is the operating voltage range. And here we can see that the operating voltage range is from 1.7 volt to 3.6 volt. You should also note this down. Please note down all the key parameters from this database and keep it handy so that you can easily access and recall them. And in the last row, we can see the available packages. So here is the left hand column. This D variant chip. It is available in this 49 pin variant, 48 pin variant, then in 64 pin variant, and then finally the 100 pin variant. And the same is the case with the higher memory variant. Now let us have a look at the communication interfaces present on this chip. And from this table we can see that it has 3 USART or serial ports. So that is very good. We can dedicate one USART especially for debugging and log printing, and still we will have 2 free USART where we can connect external peripherals like GSM modules or Wi-Fi module or any other module or a chip that supports the USART interface. And then we have the SPI ports, and we can see that some variant have 3 SPI ports while bigger chips have 4 SPI ports. This is also very nice because in one of the SPI port we will interface our ENC28J60 Ethernet controller. One of the biggest advantage of this chip is the USB OTG interface. That means this STM32F401 can act like a USB device, like a USB mouse or a USB keyboard. And it can also act like a USB host, just like a PC, where we can connect our USB keyboard, USB mouse, or even a USB pen drive. But one of the shortcomings of this microcontroller is the absence of DAC or the digital to analog converter. This forbids us to add a low cost audio output from this microcontroller. For example, if you want to play voice messages, this is not possible without adding external DAC to the system. So this is one of the shortcomings of this chip. But you can always add an external audio codec to this chip and produce audio output. But this adds to the cost and complexity of the project. Now let us have a look at the price and availability of this chip. Here I am on in.element14.com and I have searched for this STM32F401, and here I am able to find all the variants of this chip, and we can also see that the availability is very good. For example, this chip is available, the available stock is about 6,000 units, and this one also about 6,000 unit. More than 5,000 unit, more than 2,000 unit, more than 8,000 unit, near about 9,000 unit. So the availability is very good, and price is also very decent. For example, this one is 536 rupees, Indian rupees, INR 536, and this is also the retail price. You will also get a much better price when you buy them in bulk, that is wholesale. For prototyping, I use this small board which has the 48 pin variant of this chip, and it is available at a very low cost, only rupees 399, that is less than 400 rupees, and it is in India, it is available in robu.in, and I recommend you to order couple of these in order to do experiment that are described in this course. So this is it for this lesson. Thanks for watching. See you in the next lesson.